everybody, and welcome back to another video review. My name is Darren, and I hope you enjoy the show. Today we're looking at a couple of multimeters that are freely available in Canada. They're part of the Canadian Tire Mastercraft series. Specifically, the model today is the, and get ready for this, 052-0052-2. You heard it right, that is the model number. I really wish Canadian Tire or Mastercraft would actually give these things names, but anyway, it is what it is, and today we're looking at the 052-0052-2. Ugh. And from this time forward, I'm just going to call it the 052. Now, this is probably one of the top-of-the-line Mastercraft meters available. There's one more in the series that's slightly more bells and whistles than this model. That being said, that this is pretty well as good as it gets for the Mastercraft series. What you're looking at is an auto-ranging meter. It has quite a lot of functionality. It does volts, AC, DC, ohms, diode, continuity, capacitance, hertz, duty cycle, has an NCV, non-contact voltage detector, does microamps, milliamps, and amps. So it's pretty feature-packed. It is also one of the few Mastercraft meters that has a rel feature. So you can set a base for your measurements, or you can rel out your leads, what have you. That's always good to see. You can select manual range if you want to with the range button. And it does have your standard hold/backlight button. And the hold is nothing fancy. It's not like the Fluke Touch holds. Here you have to physically press on the hold button in order to save the recorded data. Now, in terms of the actual specifications, the resistance, the ohms measurement, goes up to 40 mega ohms. So it's nothing super fantastic. I mean, there's some inexpensive Chinese meters that do over 200 mega ohm. But yeah, anyway, this one's capable of a maximum 40 mega ohm. The capacitance goes up to 1,000 microfarad. I believe it will go slightly higher, but it caps off shortly after that. So you're looking at a max of 1,000 microfarad. Voltage AC/DC is rated up to 600 volts. And as you can see down here, this meter actually comes with the Intertek ETL certification. This being sold in Canada, it's both in English and French. So that's why you get the dual language on the display itself. But yeah, it's nice to see this one actually does carry an ETL rating. And here we're looking at a Cat 4 600 volt. So, what do you get in the box? Well, you get the box, you get the meter, you get a cheap pair of leads, which I'm not going to be using today. Once again, you know, the leads that these things come with, they're okay, but, you know, by all means, go out, spend $30, $40 on a really good set of leads. At the bottom of the video below, I've put links to a couple of leads that I really like. As you know, I'm a big fan of the Sanwa leads, Probe Masters, some of the Flukes, some of the Keysight. But whatever you do, you know, when you get a multimeter, I don't care how much you pay for the meter, just get yourself a good pair of leads. Alrighty, so that being said, what we're going to do is we are going to start with the backlight. Now there's some glare here, so it's not going to show up that great for you guys. Oh, and that one doesn't have a battery, so we'll have to change that. This one does. Now I'm going to turn on the backlight. And there you go. Now it's pretty washed out on the screen, but if I get it a little bit closer, I think you can see. It's actually a very, very nice, very crisp backlight. It's a deep hue green look, and in the dark, I just find this a lot easier to look at than your standard, you know, kind of a whitewashed backlight. And the nice thing about this backlight And, you know, it's really too bad that you're not getting the full effect because, yeah, it's actually a lot deeper than that. So that's a pretty good indicator right there of what the backlight looks like. And believe it or not, it's actually a little bit deeper green than what you're seeing right now. But yeah, it's very nice, very crisp, extremely even. A really, really nice display. And, you know, one of the rare exceptions in the multimeter world, this multimeter, when you turn the backlight on, it will not turn off unless you physically turn it off. So there's none of that nasty turn on the backlight and 10 seconds later it's off. That's just a pain in the butt. So really nice to see that this backlight is not only gorgeous, but it stays on. So kudos Mastercraft, as everything's about to go flying. Okay, so we're back and they're all hooked up, and I've hooked it up to the 584 voltage reference. So we're going to go through a small cycle of voltages and we'll see how close they are. Right now we're at the 10.000 volt setting, and yeah, well, you look at that, at the 5.2 here on the left is spot on. The same 5.2 but without the holster is slightly over at 10.03 counts, and the fluke spot on. And obviously the fluke is higher res, and yeah, perfect. Alrighty, going down to 2.500. Look at that. First 5.2 from Mastercraft, pretty close to 2.501. The Mastercraft in the middle, slightly over again, about 2.508. And the fluke, 87.5, reading slightly low at 2.498. Going up to the 5 volts. Wow. Check out that 052 on the left. 5.00 spot on. 5.01 for the middle 5.2, and for the fluke, spot on again, 5.000. Finally, 7.50 volts. Whoopa! Look at that. This is really amazing, actually. So this Mastercraft has pretty well been spot on at all the voltages. 7.50, 7.52. So slightly high for the Mastercraft in the middle, and slightly low again for the fluke at 7.498. So in this case, congratulations Mastercraft 052 on the left. You are the winner. Spot on. Excellent. Surprising. So it's good to see. It just goes to show you that even though these meters came off the same run at the same time, like I said, there's only about 30 or 40 digits out. There's always a margin of difference, and yeah, look at that. So perfect. I mean, I'm really actually kind of shocked that Mastercraft did so well in the voltage reference test. So excellent, good stuff. Okay, now we're going to be testing capacitance. Just a quick test here. These are both rated for 1000 microfarad maximum. I could probably go a little bit over that, but you will find, even getting up to the 1000 microfarad, that it is slow going. This unit also ships with this little device. It plugs into the common positive input jacks on the multimeter, and you can utilize it instead of probes to check capacitance. I'm not a big fan of these. For this case, we'll stick with the probes, but it does ship with one of these, so there you go. So first we're going to be looking at a small non-polarized electrolytic capacitor, and this one is rated for 22 microfarad. So we'll start with the 052 on the right, the one that is half naked. So once again, it helps if we turn it to capacitance mode. And there we go, so pretty close, 21.76. And I will just click the hold button to hold that rating. And then we'll switch it over to the 052 on the left. By the way, I'm utilizing the leads that the 052 ships with. This is what they look like. They're not bad. They're you know, a little bit of point on the tips. They're rated as a cat. Interesting, it's not on that probe. Let's see what we have here. There we go. So it's a Cat 3 1000 volt rating. 10 amps. They look a little bit like the TL75s from Fluke, but they don't feel as nice in the hand. I mean, they're okay. If I was you, I would, if you can, at least get another pair of leads, a better pair to replace these. But, you know, I've seen a lot worse. So, yeah. So we're using these probes on the 052 on the left. So once again, we're checking the capacitance of a 22 microfarad non-polarized electrolytic. And there you go. So 21.70. So pretty close to its brother on the right. Now once again, these are rated for maximum 1000 microfarad. So I do have one of those handy. And we'll just try with 1 meter, just because you will see how slow it is. So I'm going to rel it out here. All right, so that's our new baseline. And there we go. And we'll see how long it takes to go to 1000 microfarad. So there you go. So about 15 seconds or so. And it's showing slightly over at 1188. So at least you can go up to 1000. I mean, there's some new meters right now, you can't even do that. I still can't believe some meters are shipping with a maximum of 100 microfarad. Especially for hub electronics, you really need at least 1000 microfarad, I'd say a minimum. But there you go. Okay, so next we're going to be doing a quick diode test. So we'll switch to the diode. And in this case, I will just utilize the 1 meter on the right. And, oh. And there we go. So 0.563 forward voltage drop. There's no audible indicator. It's strictly a visual. If you do a lot of testing on mainboards, that, you know, audible beep or chirp, like a lot of the Flukes have, for instance, I really like. That way you don't have to actually even have to look at your display when you're doing diagnostics on a board. But anyway, there you go, 0.562. And I mean, what the heck? It's right beside it. Let's just see what we get for its brother. So pretty close. So there you go. So I'll just show you quickly this little module. How it works exactly is you just stick it in the 2 probe inputs like so. And then you can take your capacitor. In this case, it's non-polarized. Otherwise, you'd have to make sure you're putting the positive and the negative in the appropriate place. Hold it down, and you will eventually get your measurement. 21.74. So that's how that little guy works. Once again, some people like them, some people don't, you know. But it does ship with the unit. Next, we will be looking at the continuity. For the first continuity test, the 052 on the left, I will be using the stock probes that this meter ships with. And then for the 052 on the right, I will be utilizing probe masters and just compare the difference. So we'll start with the stock probes on the left. We have it set up to continuity. And by the way, I don't know if I pointed this out or not, but the S is the select switch. So in this case, the rotary dial has a couple of parameters here. You've got continuity and diode, so you utilize the blue touch button switch to select the mode you want, in this case continuity. Okay, so now that we're on continuity, let's see what we have. These are the stock probes. Here we go. So there's a delay. You know, it's not as bad actually as I thought it would be, but there's definitely some lag. And if I barely put any pressure, it's pretty well dead in the water. So you really got to put some pressure on these leads to get that continuity going. Okay, so that's the stock probes. And the guy on the right, these are the probe masters. Amazing probes, approximately $30 US. Every workbench should have at least one of these. Excellent probes, one of the best in the world. Gold tipped, but they're super pointy. They feel great in the hand, and you know, yeah, do yourself a favor, guys and girls, buy yourself a set of probe masters. Alrighty, here's the continuity with the probe master on the right. Now I'm hardly putting any pressure on these probes. So yeah, there's quite a difference. Like I said, there's basically no pressure here on these probes, and it latches all the time. Probe masters, awesome. So yeah, generally speaking, the continuity feature, it's okay. It's strictly audible. It's always nice when you get an LED or a visual indicator as well as the audible. In this case, it's strictly audible. The speaker itself, it's not super loud, it's not super quiet, but if this was a loud production environment, it would probably be a little bit hard to hear. But there you have it, that's the continuity for the Mastercraft 052. Next feature we're looking at is the NCV, also known as the non-contact voltage detection. And what that's supposed to do is alert you of a AC power source, if it finds one. And all you do is you switch it to the NCV position on the meter. Disregard what it says on the display because there's actually nothing meaningful in this case. It's strictly an audible alert. And you put it to a voltage source. And there you go. So strictly audible. It's really not super loud. I guess it's loud enough, but that's your non-contact voltage detection. Okay, so we're now on the inside of the 052, and starting over here. Now this I like. We have the probe inputs, and they are physically screwed with metal standoffs into the plastic housing. So that's always good to see. So for long-term wear and tear, that's definitely going to last longer than something that's just been casually soldered on. So good job, Mastercraft. We got a diode array down here. We have some transistors. In terms of fusing, we have a 10 amp and a 400 milliamp fuse. Both ceramic fuses. They look to be fairly decent quality. Obviously better than any glass fuse. So that's looking good. Now off the get-go, I am not seeing any MOVs or PTCs, nor do I see a current shunt, but I will be going one step further, and we'll take a look at the underneath of this as well shortly. Moving up the board, That's the 9-volt battery housing, obviously. Here we have another resistor array. We have transistors, more diodes, all SMD components. In fact, the only through hole, I don't see any through hole. I do see the oscillator over here. Speaker, the piezo. Here we have, that is probably the display driver for the IC. I'll have to double check that. So just taking a closer look at that IC, I don't see any visible markings on the exterior, so I can't determine exactly what that IC is for. Okay, so generally speaking, the overall layout is fairly clean. You've got some gaps going on here, which is always good for the input protection. I don't see any flux residue at all. In fact, this is an extremely clean PCB. Over here, we've got the conductor for the non-contact voltage detector. This is a lot better than a lot of times you'll see in cheaper multimeters, just a wire hanging, or some sort of a conduit. In this case, you've actually got a nice, basically built-in or on-board conductor that's going the length of the PCB. So in terms of the non-contact voltage detection, it's definitely going to be a lot more accurate with the device that's designed like this. Okay, so I'm going to go take it apart further and be right back. Alrighty then, so we are now on the other side of the PCB, and indeed there is the current shunt, and there is one large PTC. So there is some level of input protection at least. Would have been nice to see a few more PTCs, but it is what it is. The selector switch here is fairly small rails. They're not that thick. Very clean though, very excellent job in terms of the soldering here. It's super clean. Looks really top grade, so that's nice to see. Current shunt has a few nicks on it to increase the resistance. There's the display itself. I'm not going to go any further than this, but there you go. And if we just flip that around, you'll see where we came from. And the date on this, or do we have a date? D13986, EC-2 3616. Okay. It's not really telling me a whole lot in terms of a manufacturing date. Something else here at the top. I wonder if we can just see that. 6187. No. So I don't have a. This was purchased approximately 8 months ago, so it would have been the summer of 2017. And I'm assuming it was fairly new, run at the time. And once you see, I had to remove the standoffs for the input jacks. And here you see the soldering. So you can see what a difference it makes if you just have a standard solder on one end like that. You can see how flimsy they are. But these are actually screwed in with a metal standoff, so you have a much better mechanism for retention. Alrighty, just move that aside quickly. That's the selector switch itself. Here, once again, you can see we have these nice riveted steel inserts inside the housing for the probe inputs. That's good to see. Nice clean selector switch. This is our standard sort of push button array. And of course the LCD screen itself. There is a nice ridge runs across the multimeter here. So in terms of blast protection, arcing, what have you, yeah, nice fairly deep ridge, so that's always going to help. And finally, the back of the multimeter. To remove the battery housing, you've got the one screw that you release here. It's a brass standoff, and that's where the 9-volt battery sits. To actually change the fuse, unfortunately, you have to remove a total of 6 screws. So that's kind of a pain. So it's certainly not easy to get to replace the fuses. At least it does tell you on the back what types of fuses this meter accepts. And remember, when you do change a fuse, use the same fuse that is recommended by the manufacturer. It's really important. Do not put in different fuses. Don't replace a ceramic fuse with a glass fuse, what have you. Always do what the manufacturer says. In this case, once again, this is a ETL confirmed standard, so it's certified for a CSA here in Canada. So this has met some safety requirements. And finally, this is the standing bail that comes off. If you want to replace the battery, it's just this one piece that you remove, and has the date of manufacture here, October 2016. I don't know if that'll be the same as the PCB, but I'm sure it's fairly close. And there's the serial number. Once again, made in China, but last but not least, if we flip it over without losing all of the screws, disappointing, but there is zero input, and I'm sorry, not input protection. There is zero shielding on the back. Yeah. Really disappointing. I really wish that would be just, a de facto standard for any meter manufacturer, but because these things are always in surroundings that have, some sort of EMF involved, and, I really would like to see shielding in any multimeter, no matter how expensive or inexpensive. But once again, there's absolutely no shielding in this multimeter, so that's definitely 1 star goes away for that. Okay, so I'm going to put the pieces back together, and then we'll come back with a final thought on the... So final thoughts on the Mastercraft 0052-2 Autoranging multimeter. Generally speaking, I'm quite happy. I think for a Mastercraft product, at least, Mastercraft is the equivalent of Craftsman down in the United States. There's a lot of crappy products that come out of Mastercraft, but that being said, this is one of those that I would definitely not call crappy. It's a decent multimeter. If you could get it on sale like I did for around $30 or $40, it's great. I'd hasten to say that it's probably worth even the $59, the normal retail price. It's auto-ranging, has a gorgeous display, really nice backlight that stays on all the time. Auto powers off after 15 minutes. Has a lot of features, a lot of functionality. I wish it had a higher capacitance range. It doesn't. I wish it had a slightly better input protection, but at least it has some, and it does use ceramic fuses. PCB, generally speaking, is very well made, as you can see, very clean, very nice design, not sloppy at all. The NCV detector is actually high quality, so generally you're getting a lot of bang for the buck. So for the Mastercraft 052 multimeter, I'm giving a solid 4 out of 5 stars. Thanks for watching. I hope you enjoyed this review. February of 2018, I'm doing a Japanese multimeter showdown with at least 3 Japanese multimeters, possibly more. So stay tuned for that. And until the next time, keep on testing.